Hello, Algebra. Today we are going to move on to 2.3, standard form of a linear equation. The standard form of a linear equation is ax plus by equals c. As you can tell, there's no m in here, so you cannot just tell the slope, but it's its own thing, right? Ax plus by equals c, where a and b need to be real numbers. A, b, and c are real numbers. A and B are whole numbers, and the A must be a positive whole number. All right, so this is just like a literal equation. You're moving things around to make sure it looks visually like that. So if I have negative 2y equals negative 3x plus 6, I need to move this around so that the A is in front. So we have the left side here and the right side of the equation of the equal sign. When we need to make sure that this 3x is on the left side. How do I do that? I will use inverse operations. I would add 3x to both sides. And when I do that, I want to make sure this x is in the front and not behind the 2y. So then I would write 3x minus 2y, and that's equal to 6. This is now in standard form. Ax, by, and is equal to a number, c. In order to get to standard form, I usually come from another form, whether it's slope intercept or point slope, or, just something like number 3. I have to come from somewhere in order to get there, but I don't just get there directly from 2 points. If I want to get y by itself here, I see again, y is over here on the right side being divided by 3. So I can move the whole thing by subtracting y over 3 on both sides. When I do that, I don't want to put it in front of the 2x. I want to put it behind it so that it looks like ax by equals c. So then I will have 2x minus y divided by 3, and that's equal to negative 4. Well, we also said that a and b had to be whole numbers, and this is not a whole number, it's a fraction. So I need to clean this up. I could get rid of that denominator by multiplying both sides by 3. So now 3 times 2 will give me 6x, and 3 times negative y will give me negative 3 over 3y, and that's equal to negative 12. I just did that so we could see where I'm going to get this negative y from. Ax by equals c. Yes, this is in standard form. Go ahead and pause and try number 3. Right now that you're back, I want us to go ahead and solve. So my goal again, I see there's a left side and a right side of the equal sign. I need my x's to be in the front and then my y's equal in just a number. So if I look, I see that there's a 2y on the right side. The 2y has to move over. So I'm going to minus 2y using inverse operations. I'm going to get it over. So that 3x minus 5 minus y, 1 minus 2 is negative 1. And that's equal to negative 4. If I look on the left side now, I also see that there's a 5, just a regular number. Doesn't belong there because it's ax by. Something else is here. So I'm going to get rid of just that number by adding 5. Again, inverse operation is how I move across the equal sign. So I'm using the addition property of equality here. And it's 3x minus y. That's equal to positive 1. Ax by equals c. Yep, I am in standard form. If I want to graph in standard form, I am going to have to graph using the intercepts. So I could find the x and y intercepts. Let's see. This is a 3. I'm going to find the x and the y intercept. To find the x-intercept along the x-axis, I have to think all my coordinates. This is 4, 0, 3, 0, 2, 0, 1, 0. That means anywhere along the x-axis coordinate-wise is going to be a number and then 0. That's 0 representing the y. On the x-axis, the y value is always 0. So to find the x-intercept, I'm going to replace y with 0 and solve for x. So for the x-intercept, y equals 0. That means 3x minus 2y is equal to 12. To find x, y is 0, so 3x minus 2 times 0 is equal to 12. We could go through the whole song and dance. Equals 12. Then you would add 0 to both sides, but 0 is just 0, right? So 3x is going to be equal to 12. Then you would divide both sides by 3, and your x is equal to 4. So your x-intercept is at 4. To find the y-intercept, anywhere along the y-axis, x must be 0. So this coordinate is 1, 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2. Anywhere along the y-axis, your x value, if you notice, is 0. So for the y-intercept, your x must be equal to 0. If your x is 0, you can substitute 0 in for x to find y. So again, the equation, 3x minus 2y is equal to 12. If x is 0, I'm going to substitute 0 in for x. So that 0 minus 2y is equal to negative 12. I'm not negative 12, just 12. Sorry. And then I would add 0 to both sides. Again, it's nothing. So do I need to? No. However, that's how we would get rid of that. I'm going to divide both sides by negative 2. So that y is equal to negative 6. My y-intercept is negative 6. Now that I have those 2 points, any 2 points create a line. So, boom. There is my linear function, my line graphed in using standard form. Now, to be fair, if you really want, and just imagine me taking my finger and covering it over the y. If I want the x-intercept, I know that y is 0, right? So I don't know how to tell. We're going to pretend like this is not there. Put your finger over the y. If you put your finger over the y, then you actually are just left with this. 3x equals 12. And you can solve. Because again, no matter what you do, anything times 0 is 0. So that's just a little shortcut. For the x-axis, if you want the if you want the y, you're going to cover up the x. So put your finger over this green part, the 3x, and then you would have come down here to this equation, which is just negative 2y equals 12. And you would save yourself a lot of this portion in here. All right, now let's go ahead and use that concept to do number 2. We are going to find the x-intercept. Oh my goodness, something is wrong. We will see that this is not in standard form. So I can't really do that yet. I want to move this around to get it to standard form, and then I'm going to work my magic. So I would minus 4y on both sides. So that 2x minus 4y is equal to 8. Now it's in standard form. Now I can graph from those intercepts. So I'm going to go ahead and to find the x-intercept, I'm going to cover up that y, kind of ignore it. So that 2x is equal to 8. And I divide by 2. My x-intercept again is at 4. For the y-intercept, I'm going to cover up the x. So that 4y is equal to 8, negative 4y with that sign in front. And then I would divide both sides by negative 4. So that y is equal to negative 2. My x-intercept again is at 4. And my y-intercept is over here at negative 2. There's my graph. Now let's go ahead and we're going to check out, a word problem. When we come to a word problem, we are going to read it just so we know what it's saying to us. P.S. I should have asked you, what is the domain of this function? Yes, the domain is going to refer to all our x values. And then this is a continuous line. You see the arrow at the end and the arrow at the end tells me that it continues forever. That means your x is going to be all real numbers. Sometimes you might see it as the x such that it's negative infinity, x to positive infinity, and your alligator will chomp to the right. For the range, it's actually going to be similar. The range refers to your y-axis, but those arrows, again, they're continuing. That means it's every y value going up and every y value going down. So that the range will be referring to all your y values such that it's all real numbers. Negative infinity to positive infinity as well. All right, now let's look at number 3. When we see a word problem, first thing we do is read it. It says there's a fishing lake and it's stocked with 300 bass. Each year, the population is decreasing by 25. The population of bass in the lake after X years is represented by the function f of x equals 300 minus 25x. One, they want you to graph the function and its intercepts, and they want to know what does each intercept represent. So for me, I'm going to write out the equation first of all. F of x is equal to 300 minus 25x. It looks to me very close to slope intercept. I would have to move that 25x around, but it can be done. But they also want me to do intercept. So for this particular purpose, I'm going to stick with the standard form so I could get the intercepts easier. F of x, that's weird too. But I also remember that f of x is the same as y. So if I rewrite this, that makes more sense to me. And then I can add 25 on both sides, 25x, so that it looks like standard form. Now I have 25x plus y, and that's equal to 300. There we go. This is in standard form. So now that I know this is in standard form, in order to find the x-intercept, again, I'm going to pretend like the y is not there. And I would have 25x is equal to 300 because y is going to be 0. I would divide both sides by 25, and my x-intercept is at 12. My y-intercept, I ignore the x because 25 times 0 will be 0, and it's going to cancel out. So that y-intercept is just the y equals 300. My y-intercept is 300. All right, so now I'm going to graph it. Here's my axis. When I'm graphing, I always want to use what do I know? I know the x-intercept is at 12. So then maybe this is 0. I want to go by 2s. 4, 6, 8, 10, 12. Could I just go by 6s? I could have 6 and 12. That's fine. I just wanted to spread it out a little bit. My y-axis, I know I have to go to 300. So am I going to start numbering 1, 2, 3, 4, 5, 6, 7, 8? No. I'm probably just going to do 100, 200, 300. All right. And then it told me that the X is representing the years, right? So this is your years, number of years. And the y-axis, it's been talking about bass. So maybe it's going to be the number of bass in the lake. So now my intercepts are here at 12 and 300. There I go. You might say, Miss Reed, why did you not keep going on this? Well, down here would be negative numbers, right? Can you have negative bass in a lake? Negative amount of fishes? No. So I wouldn't be using the negative area there. And I'm talking about numbers of years on my x-axis. Would I have negative years? I can't do that either. And so because of that, I'm really only using quadrant 1. Okay. So now they want to know, what does this represent? The y-intercept, which is here at the thing, what does that represent? Well, they told me in the beginning, the bake was stocked with 300 bass. That's my starting point. That's my beginning. So the y-intercept, that beginning, is here at, what's this, 0, 300. So if you recall, X is representing your years, and this is your number of bass. So at 0 years, there was 300 bass. You could also say, at the beginning, there was 300 bass. Started with 300 bass. Something of the sort, right? That's up to you. And then our x-intercept is here at 12. This is 12, 0. So 12 on the x, 12 is the number of years, 0 on the number of bass. That's going to tell me that after 12 years, look, it came all the way down to 0. After 12 years, there were 0 bass. So after 12 years, all the bass was out the lake. All right. Now let's go ahead and talk about the domain and range. It doesn't ask you for that, but I'm using this to also review. So if I'm looking at the domain, again, the domain is referring to all my x values. Use another color for that concept. So I look at my x value. Here's my thing coming down. And this is my lowest x. And this is my highest x. So I could see that this function, kind of like the compound inequality, is going between 0 and 12 for your x. So your domain is all the x values, where your x is between 0 and 12. And this is continuous, right? So not just 2, 4, 6, 8, because there's also a 7. There's also a 5 on that continual graph. This fractional portion of years, maybe months, right? And so the alligator chomps to the right, your x is greater than 0, and it's less than or equal to 12. So any number between those. For your range, you want to look on the y-axis. Your lowest y value for this function is 0, and your highest is 300. So your y is every value between 0 and 300. It's every y value between 0 and 300, and your alligator chomps to the right. All right, that's it for this lesson. Remember, in order to learn your mathematics, you must do your mathematics. Until next time.